Hi, my name is Greta Meshke, and today I'm presenting my genetic disorder, congenital adrenal hyperplasia, or CAH. What is CAH? CAH is a group of inherited disorders of the adrenal glands. The adrenal glands are walnut-sized organs located at the top of each kidney and produce hormones that are crucial for the body's hemostasis. The hormones include cortisol, that regulates the body's response to stress and illness, aldosterone, that regulates the body's potassium and sodium, and androgens like testosterone, that are male sex hormones. CAH is caused by mutation in genes which lead to deficiencies in the enzyme 21-hydroxylase. This enzyme is needed to produce the hormones of the adrenal glands. Characteristics of CAH. About 1 in 10,000 to 18,000 children are born with CAH, and it affects both females and males. There is no cure for this disorder, but with proper treatment, individuals can lead a normal life. There are two types of CAH. Classic CAH is less common and is discovered in infancy, with the salt-wasting form and the simple virilizing form. Symptoms include female infants will be born with ambiguous genitalia, where the clitoris is enlarged and can look more like male genitalia. Males have normal-looking genitalia. Females and males may have life-threatening adrenal crisis from lack of cortisol and aldosterone. Females and males may have difficulty regulating blood pressure, normal blood sugar, and response to stress from lower levels of cortisol. Severe life-threatening symptoms from salt wasting include poor feeding, vomiting, dehydration, electrolyte changes, and abnormal heart rhythm. An excess of male hormones may result in shorter than average final height and early signs of puberty in both females and males. Non-classic CAH is milder and more common. It is not usually discovered until childhood or early adulthood. Symptoms include females may have irregular or absent menstrual periods. Females may have masculine characteristics like unwanted facial hair, excessive body hair, and deepening voice. Females may have severe acne. Females and males may have an early appearance of pubic hair. Females and males may have shorter than average final height. And this picture just demonstrates the male characteristics: excessive body hair, small breasts, facial hair, enlarged clitoris that looks more like male genitalia. Molecular cause of CAH. The CYP21A2 gene is responsible for making instructions to produce an enzyme called 21-hydroxylase, which is part of the cytochrome P450 family of enzymes. Cytochrome P450 enzyme assists in many systems in the body, such as reactions that break down drugs and helping to produce cholesterol, certain hormones, and fats. There are over 100 mutations in the CYP21A2 gene to cause 21-hydroxylase deficiency, and some of the mutations are caused by a gene conversion on chromosome 6. This gene conversion is an exchange of genetic material between the CYP21A2 gene and a similar but non-functional piece of DNA called a pseudogene, which is close to the CYP21A2 gene on chromosome 6. These errors disrupt the ways a gene's instructions are used to produce a protein. Other mutations that cause 21-hydroxylase deficiency change single protein building blocks or amino acids in the 21-hydroxylase enzyme, or they delete or insert pieces of DNA in the CYP21A2 gene. There are 3 types of 21-hydroxylase deficiencies, including the salt-wasting type that results in a complete non-functional enzyme, simple virilizing type that has low levels of functional enzyme, and the non-classic type that results in a reduced amount of enzyme. All types of this enzyme deficiency interfere with the production of cortisol and aldosterone, which then build up in the adrenal glands and are converted to androgens, the male sex hormones. The abnormal sexual development that occurs in this condition is from excess production of these male hormones. Mode of inheritance. All types of CAH are inherited in an autosomal recessive manner, and it is a genetic endocrine disorder. An individual must have a mutation in both copies of the responsible gene in each cell to be affected. Each parent of an individual affected with CAH will carry one mutated copy of the gene and are called carriers. Carriers of CAH do not usually exhibit the disorder, but when 2 carriers of an autosomal recessive condition have children, Each child has a 25% risk of having CAH, a 50% risk to be a carrier, and a 25% risk of not having the condition or being a carrier. I included the Punnett squares that I did for our assignments. In scenario 1, both parents have the recessive disorder, and so all of their offspring will have the disorder of CAH. Scenario 2 shows one parent that has the disorder and one that does not and is not a carrier. And it shows that none of the children will have the disorder, but they will all be carriers. And scenario 3 shows a parent with the disorder and one that is a carrier. And this shows a 50% probability of having CAH and a 50% probability of being a carrier. Scenario 4 shows two parents, neither one of them having the disorder or being a carrier, and none of their children will have the disorder or be a carrier. And this just again shows a picture of a mother and father both being carriers, and the affected child 25%, carriers 50%, and unaffected child being 25%. I included the pedigree for CAH that I used in our assignment as well, and I'll go over this briefly. Just you can see with Robert and Janet. Janet is has the disorder, and Robert is a carrier. They have 4 children, and they have 50% probability of having a child with CAH. They do have 1 child, Greta, with the disorder, and the other 3 are carriers. You can see Jill and Stan Mary, they are both carriers, and they have a 25% probability of having a child with CAH. And you can see Amelia has the disorder, and Noah does not have the disorder and is not a carrier, but Maria and Allison are carriers. You can see Greta, who has the disorder, marries Tim, who has the disorder as well, and they have 100% probability of having a child with CAH. And you can see Tyler has a disorder. Aaron and Lily are both carriers, and they have a 25% probability of having a child with CAH, but both of the children they had are both carriers. And Nathan and Tricia Mary, they are both carriers, and they have a 25% probability of having a child with CAH. And you can see Oliver has the disorder, and then they have 2 children that are carriers. Genetic testing for CAH. Required newborn testing is mandatory in the USA for 21-hydroxylase deficiency that is the most common cause of classic CAH. Non-classic CAH is not detected through the screening but is diagnosed later as symptoms appear. Carrier and prenatal testing is optional and can be done prior to birth through amniocentesis and chorionic villus sampling if the gene mutation CYP21A2 is known in the family. Early detection is important in both females and males. In severe forms, males may seem unaffected at birth but may develop characteristics health problems soon after birth. There is an increased risk of death if not treated early. Most states charge a fee for newborn screening between $15 to $100, and it is covered by health insurance. Prenatal and carrier testing charge a fee between $100 to $2,000, and it is sometimes covered by health insurance. There are several companies that provide this testing, including Blueprint Genetics and Prevention Genetics. There is controversy on whether genetic testing should be carried out on unaffected individuals. As this is a genetic recessive disorder, it is very important to carry out testing, as the parents could be carriers and are unaware as they do not exhibit the disorder. This disorder requires immediate attention and can be life-threatening without treatment. There is also controversy on whether surgical treatment of females with ambiguous genitalia should be performed based on genetic testing, since these individuals are genotypically female. And this is a list of my references for the presentation. Thank you.